Good afternoon, students. So in the previous class we learned the topic enthalpy. See, now we are going to learn about the topic measurements of delta U and delta H. Our next topic delta U and delta H. How we can measure delta U and delta H. How we can measure this means by using calorimeter. See, this calorimeter is used to measure the amount of heat change. The calorimeter is used to measure the amount of heat change. And according to this, by using this calorimeter, we can measure the temperature. We can note the temperature. Temperature measured is directly proportional to the heat capacity. Temperature is directly proportional to the heat capacity. So listen, by using calorimeter we can measure the delta U and delta H. And this calorimeter is used to measure the heat change. The next, according to this, by using this we can note the temperature. This temperature measured is directly proportional to the heat capacity. Now listen, by using this measurements we can write one expression. For this expression we can write the relation Q is directly proportional to, say we can write C is equal to heat capacity, C is equal to Q divided by M into delta T. For this expression we can write C is equal to Q divided by M into delta T. C is equal to Q divided by M into delta T. From this we can calculate the amount of heat change Q. Understand? Now listen. For this measurements are made under two conditions. One is measurements takes place at constant volume. And another one is measurements takes place at constant pressure. These measurements are made of two conditions. First condition, measurements takes place at constant volume, and another one condition, measurements takes place at constant pressure. First one is measurements takes place at constant volume. This constant volume only we can calculate the measurement of delta U. So your first topic, measurements of delta U at constant volume. See, listen. At constant volume, we can calculate the amount of heat. At constant volume, we can calculate the amount of heat. How we can calculate the amount of heat means by using the apparatus bomb calorimeter. Using this bomb calorimeter only we can calculate the amount of heat. So listen the process. The inner vessel and its cover. The inner vessel and its cover are made of. So listen. The inner vessel, you can consider small. The inner vessel and its cover are made of strong steel. See the process? The inner vessel and its cover are made of strong steel. See, now this cover is tightly fitted to the metal lid and screws. This cover is the inner vessel. This vessel is closed condition. This is inner vessel. This inner vessel and its cover are made of. The sun and its cover are made of strong steel. Inner vessel and its cover are made of strong steel. Now this cover is tightly fitted to the metal lid and screws. This cover is tightly fitted to the metal lid and screws. This cover is tightly fitted to the metal lid and screws. Understand? Then next listen. A weighed amount of the substance is taken in a platinum cup. Inside on platinum cup present. Here it take the amount of substance. A weighed amount of substance is taken in a platinum cup. A weighed amount of substance is taken in a platinum cup. This one connected with the electrical wires. Here you are going to connect the electrical wires. Electrical wires. So this one connected with the electrical wires. This one connected with electrical wires. The bomb is then tightly closed. Now you are just to close this apparatus. This one is tightly closed. This platinum cup, this one only we are telling bomb. And this one is tightly closed. This one is tightly closed and pressurized with the excess of oxygen. And pressurized with the excess of oxygen. You can apply excess of oxygen. So listen. First the inner vessel. This one only we are telling inner vessel. Why we are telling inner vessel means this one only outside only the apparatus calorimeter present. So we are telling this is inner vessel. So inner vessel and its cover are made of strong steel. Inner vessel and its cover are made of strong steel. Now this one is the cover is tightly fitted with metal lid and screws. This one is tightly fitted with metal lid and screws. Then you connect the platinum cup. A weighed amount of substance is taken in the platinum cup. A weighed amount of the substance is taken in a platinum cup. Here electrical wires present. You can connect the electrical wires. You can connect the electrical wires. And this bomb is tightly closed and pressurized with the excess of oxygen. This one is tightly closed and pressurized with the excess of oxygen. Understand this? Now listen. Now this one is immersed in water. This one is immersed in water. This bomb is immersed in water. Fully water molecule present. This apparatus inside fully water molecule present. So this bomb is immersed in water. This one is immersed in water. Then you can connect the stirrer. You can connect the stirrer to stir the water molecule. So you can connect the apparatus stirrer. You can connect the apparatus stirrer. Then you can connect the thermometer. You can connect the thermometer. You can connect the apparatus thermometer. Understand? Understand? Now listen, tell the process. You know the process. The inner vessel and its cover are made of strong steel. Then this cover is tightly fitted with metal lid and screws. Metal lid and screws. Now platinum cup, you are connecting platinum cup. Platinum cup is connected with, a weighed amount of the substance. The particular substance is taken in a platinum cup and this one is tightly closed and pressurized with the excess oxygen. And you are connecting electrical wires. Then here you fit the stirrer and thermometer. Understand? Now listen. The substances by using electrical heater. By using electrical heater, you just heat the substance. By using electrical heater, you just heat the substance. If you heat this, the substance fully burned in oxygen. The substance fully completely burned in oxygen. If you just heat this mixture, if you are heating, the substance fully burned in oxygen. The substance fully burned in oxygen and you will get the heat evolved. Heat is evolved. Substance fully burned in oxygen and heat is evolved. Heat is evolved. And by using this process, we can measure by using this thermometer at this time, by using this thermometer, we can measure the temperature. Now this time, see, by using this electrical heater, just heat the substance. If you are heating, heat is evolved. Heat is evolved. At this time, by using this thermometer, we can note the temperature. We can note the temperature. And this thermometer name we are telling, that is Beckman thermometer. Beckman thermometer. Understand this? Understand everyone? See here, this heat evolved is equal to the heat evolved Q is equal to the heat of combustion at constant volume. Heat evolved is equal to the heat of combustion. Heat evolved is equal to the heat of combustion. Heat of combustion at constant volume. Heat evolved. By using this process, heat is evolved. This heat evolved is equal to the heat of combustion at constant volume. Heat of combustion at constant volume. Understand this process. One more time listen. The inner vessel and cover are made of strong steel. Inner vessel and cover are made of strong steel. And this cover is tightly fitted with metal lids and screws. Then a weighed amount of the substance is taken in a platinum cup. Here we are connecting the electrical wires. Then this one is fitted with the tightly closed and pressurized with the excess oxygen. Pressurized with the excess oxygen. And here water molecule present. Then we are connecting stirrer and thermometer. Stirrer and thermometer. By using electrical heater, if you heat this mixture, completely this mixture burned in oxygen and heat is evolved. This heat evolved is equal to the heat of combustion at constant volume. This heat evolved is equal to the heat of combustion at constant volume. Understand? See, listen. Amount of heat produced in this reaction. Now we learned one topic on process. Here amount of heat produced in this reaction at constant volume. Amount of heat produced in this reaction is equal to the sum of the amount of heat absorbed by calorimeter and amount of heat absorbed by water. Amount of heat absorbed by calorimeter and amount of heat absorbed by water. So listen, amount of heat absorbed in this expression, in the calorimetric expression, is equal to the amount of heat absorbed at calorimeter and sum of the amount of heat absorbed by calorimeter and heat absorbed by water. Understand? Now separately we can calculate first amount of heat absorbed by calorimeter. Amount of heat absorbed by calorimeter Q1 is equal to constant K1 into delta T. Amount of heat absorbed by calorimeter Q1 is equal to K1 into delta T. Same way you can calculate the amount of heat absorbed by water. Heat absorbed by water formula Q2 is equal to MW into CW into delta T. MW into CW into delta T. Here what is meant by K? K1 is, this one is calorimetric constant. K is calorimetric constant. K1 is calorimetric constant. And delta T, you know, that is temperature difference. Temperature difference. Understand? And you know this K1, this calorimetric constant K1 is equal to MC into Cc. Calorimetric constant K1 is equal to MC into Cc. MC into Cc. MC is mass of the calorimeter. Here MC is mass of the calorimeter. And what is meant by Cc? C means heat capacity. C means heat capacity. So Cc is heat capacity of the calorimeter. So listen. First Q1 formula. Heat absorbed by calorimeter Q1 is equal to K1 into delta T. K1 is calorimetric constant. K1 formula MC into Cc. MC is mass of the calorimeter. Cc is heat capacity of the calorimeter. Understand? Then listen. Another term, heat absorbed by water. Heat absorbed by water Q2 is equal to MW into CW into delta T. Here what is meant by MW? MW means that is molar mass of the water. MW means molar mass of the water. And what is meant by CW? C is heat capacity. So CW is heat capacity of the water. CW means heat capacity of the water. And delta T you know that is temperature difference. Understand? So you got two formula. Heat absorbed by calorimeter and heat absorbed by water. From this you can calculate the delta UC. Tell the formula. Delta UC is equal to heat absorbed is equal to heat absorbed by calorimeter. So you know that is Q1 and heat absorbed by water is Q2. Tell the answer. Q1. Q1 is equal to K1 into delta T plus Q2 MW into CW into delta T. Understand this? Understand? See here, delta T is common in these two terms. So you can take this delta T outside. So tell the formula. Delta T into, if you are taking delta T outside, you will get the answer K1 plus MW into CW. MW into CW. Understand? Here you know K1 means calorimetric constant. K1 means calorimetric constant. How we can calculate this means? This calorimetric constant can be measured by burning a. This calorimetric constant K1 can be calculated. Can be measured by burning a sample benzoic acid. You take any one example. Here you consider the example benzoic acid. You consider the example benzoic acid. Just burn this benzoic acid. By using this you can calculate the, by using this sample you can calculate the calorimetric constant K1. Calorimetric constant K1. And in this benzoic acid, heat of combustion value you know, heat of combustion value you know, that is the constant value, minus 3227 kilojoule per mole. Minus 3227 kilojoule per mole. Understand? Understand? So by using this expression, we can calculate the calorimetric constant K1. Now listen. Already you know the formula enthalpy. You know the formula enthalpy. Tell the formula enthalpy. Enthalpy change delta H is equal to delta U plus PV. And one derivation we applied the PV value. If you applied PV value, got the answer. Delta H is equal to delta U plus delta NG RT. P delta V. So delta H is equal to delta U plus delta NG RT. And here we can write the formula enthalpy of combustion. Enthalpy of combustion. So delta H of combustion is equal to delta U of combustion plus delta NG RT. So tell the formula. Enthalpy of combustion delta H. Enthalpy of combustion delta H combustion is equal to delta UC plus delta NG RT. And here we can write the standard enthalpy of combustion. So standard enthalpy of combustion formula, delta H naught combustion is equal to delta U naught combustion plus delta Ng RT. Delta Ng RT. Understand? So this one only by using bomb calorimeter. By using bomb calorimeter. This is the expression. By using bomb calorimeter, we can calculate the amount of heat change. By using bomb calorimeter, we can calculate the amount of heat change. Understand? Understand this topic? Any doubt? Okay. See now the next topic, applications of bomb calorimeter. Applications of bomb calorimeter. By using this bomb calorimeter, we can calculate the amount of heat. By using this apparatus bomb calorimeter, we can calculate the amount of heat released in combustion reaction. We can calculate the amount of heat released in combustion reaction. Then second application, by using this, we can calculate the calorific value of food. By using this bomb calorimeter, we can calculate the calorific value of food. What is meant by calorific value? Calorific value means amount of heat produced. Amount of heat produced in calories. Amount of heat produced in calories. Say listen. By using this bomb calorimeter, we can measure this one is used to determine the calorific value of food. Calorific value of food. Calorific value means amount of heat produced in calories. Amount of heat produced in calories. When 1 gram of substance is completely burnt. When 1 gram of substance is completely burnt. Understand? So listen. It is used to determine the calorific value of food. Then third application, by using this one is used in many industries. This bomb calorimeter is used in many industries. What are the industries means? Metabolic study. This one is used in metabolic study, metabolisms. Then second one, this one is used in food processing. This bomb calorimeter is used in food processing. Then one more, this one is used in explosive testing. This one is used in explosive testing. So listen, totally 3 applications. First application, bomb calorimeter is used to determine the heat produced. This one is used to determine the heat released in combustion reaction. Heat released in combustion reaction. Second application, this one is used to determine the calorific value of food. Calorific value of food. Then third application, this one is used in many industries. What are the industries? Metabolic study, food processing and explosive testing. Understand this? Understand this topic? Okay, listen. Now the next topic, delta H measurement. Already you learned delta U measurement by using bomb calorimeter. Here the next topic, delta H measurement. Delta H measurement at constant pressure. Delta H measurement at constant pressure. Heat evolved at constant pressure by using coffee cup calorimeter. Delta U measurement we learned bomb calorimeter. This one is coffee cup calorimeter. This one is calculated. Heat evolved at constant pressure is measured by using coffee cup calorimeter. Coffee cup calorimeter. Instead of bomb. Instead of bomb. There we learned bomb in the bomb calorimeter we used bomb. Instead of bomb we are using styrofoam cup. We are using the cup. Styrofoam cup. Instead of bomb, we are using styrofoam cup. Styrofoam cup. This one is used in calorimeter. So instead of bomb, we are using styrofoam cup. Styrofoam cup. and this one does not allow transfer of heat. Why we are using this styrofoam cup means this one does not allow transfer of heat. This one does not allow the transfer of heat during the reaction. This styrofoam cup does not allow the transfer of heat during the reaction. Now listen, you know the styrofoam cup is this one only. This is the styrofoam cup. Styrofoam cup. Here also the same way this one is made of strong steel. This cup also made of strong steel. Here also we are connecting. This one is closed with the lid and we are connecting stirrer and thermometer. We are connecting the stirrer and thermometer. Understand? So listen. This cup does not allow the transfer of heat during the reaction. When the reaction takes place, this one does not allow the transfer of heat. And by using this apparatus, we can measure the heat absorbed. And by using this temperature, here also we can use the electrical heater. If you heat this mixture, here you take the particular substance. If you heat this mixture, you can, by using this thermometer, you can note the temperature. So listen, this process is very simple. Instead of bomb, we are using styrofoam cup. And here also we are connecting stirrer and thermometer. And you take the particular substance. If you do this process by using electrical heater, this apparatus does not allow the transfer of heat. And by using this, we can note the temperature. Understand? And by using this expression, we can write the amount of heat formula. Amount of heat Q is equal to mW into Cw into delta T. Amount of heat Q is equal to mW into Cw into delta T. Already you know mW and Cw. What is meant by mW? mW is molar mass of the water and Cw is heat capacity of the water. Understand this? Now listen, totally 2 topics we learned today. What are the topics? Delta U measurements and delta H measurements. Delta U measurements and delta H measurements. Delta U measurements means by using this one measured by using bomb calorimeter. At the same way, delta H can be measured by using coffee cup calorimeter. Understand this topic? Understand? Any doubt? See now page number 202. Page number 202. Just underline this topic. Calorimeter is used for measuring the amount of heat change in a chemical and physical change. And here temperature change is directly proportional to the heat capacity. And here we are writing the expression C is equal to Q divided by M into delta T. And this one only the topic. Calorimetric measurements are made under 2 conditions, constant volume and constant pressure. This is the first question, delta U measurements. Delta U measurements. How we can calculate the heat evolved? At constant pressure means. Note the topic fully. Here heat evolved at constant volume is measured in a page number 203 in a bomb calorimeter. And note the topic. This is the diagram. See the diagram and learn the topic. Inner vessel and its cover are made of strong steel. Here inner vessel is this one. This inner vessel and this cover are made of strong steel. And the cover is tightly fitted to the vessel by means of metal lid and screws. And this cover is tightly fitted to metal lid and screws. This is metal lid and connected to screws. The next, A weighed amount of the substance is taken in a platinum cup. Here this is platinum cup. Weighed amount of the substance is taken in a platinum cup. That one is connected with electrical wires for striking an arc instantly to kind combustion. And here we are connecting the electrical wires for the combustion process, burning process. We are connecting the electrical wires. Then next, the bomb is then tightly closed and pressurized with excess oxygen. This bomb is tightly closed and pressurized with excess oxygen. Then the bomb is immersed in water, and this one is immersed in water. Outside fully water molecule only present. Immersed in water in the inner volume of the calorimeter. Then the stirrer is placed in the space between the wall of the calorimeter and the bomb. We connected the stirrer. This is stirrer. And so that water can be, why we are connecting the stirrer means water can be stirred uniformly. The reaction is started by using electrical heating. Just we are heated by using electrical heater. Reaction is started. A known amount of the combustible substance is burned in oxygen in the bomb. We start the process. The substance fully burned in oxygen in the bomb. Inside the bomb, the substance fully burned in oxygen. Then at this process, heat evolved during the reaction is absorbed by the calorimeter as well as the water in which the bomb is immersed. Then we are measuring the temperature. The change in temperature is measured by using a Beckman thermometer. And bomb is sealed, its volume does not change, and hence the heat measurement is equal to the, here heat measurement is equal to the heat of combustion at a constant volume. So by using this expression we can calculate the heat produced. This one is equal to sum of the heat absorbed by calorimeter and heat absorbed by water. First they calculated heat absorbed by calorimeter. Q1 is equal to K into delta T. Here K means calorimeter constant. K is equal to MC into Cc. Here MC is mass of the calorimeter and Cc is heat capacity of the calorimeter. Then same way you can calculate heat absorbed by water. Q2 is equal to MW into Cw into delta T. MW molar mass of water, Cw heat capacity of water. Understand? Then page number 204. You learn this one is equal to sum of the heat absorbed by calorimeter and water. So Q1 plus Q2. Q1 value K into delta T. Q2 value this one. From this if you are taking delta T outside, K plus MW into Cw. Understand? Then calorimeter constant can be determined. This K can be determined by burning a substance, benzoic acid. In this benzoic acid, heat of combustion value is known. Then from this they return the enthalpy of combustion formula. Delta H naught C is equal to delta U naught C plus delta NG into RT. Till this you just note the topic. How we can calculate the delta U by using bomb calorimeter. Then next applications. This is separate 3 more question. Read the application. Note this topic from this to till this explosive testing. Bomb calorimeter is used to determine the amount of heat released in combustion reaction. Then determine the calorific value of food. And this one is used in industries. What are the industries? Metabolic study, food processing and explosive testing. Understand? The next question, delta H measurements. How we can calculate delta H? By using coffee cup calorimeter. Note the topic fully from this too. So heat change at constant pressure can be measured using coffee cup calorimeter. Here instead of bomb we are connecting styrofoam cup. Then it acts as a good adiabatic wall and does not allow the transfer of heat produced during the reaction to its surroundings. And this entire heat energy is absorbed by the water inside the cup. This heat energy completely absorbed by the water molecule present inside the cup. This method can be used for the reactions where there is no appreciable change in volume. There is no change in the volume. There is no change in the volume. Then change in the temperature of water is measured and this one used to calculate the amount of heat that has been absorbed or evolved in the reaction. We can note the temperature and measure the amount of heat. Formula Q is equal to mW into Cw into delta T, where mW you know that is molar mass of water and Cw is molar heat capacity of water. And note the diagram. So you just more till this. This is separate topic, coffee cup calorimeter. Understand this? Any doubt? Okay, see now take page number 225. Question number 48. Question number 48. Explain how heat absorbed at constant volume is measured using bomb calorimeter with a neat diagram. Question number 48. Page number 202. Page number 202. From this to, for a chemical reactions, heat evolved at constant volume. From this to page number 204 till this relation. Delta H naught C is equal to delta U naught C plus delta Ng RT. Understand this? Understand? So listen. Now note the next day's homework. This two topic. Bomb calorimeter and coffee cup calorimeter. Bomb calorimeter and coffee cup calorimeter. Here you must learn the applications also. So these three questions study thoroughly. Understand? Okay, thank you.